All right, so welcome to lecture 17. My name is Harmtedy. So we're going to look at practical questions on logarithms and exponential functions. Okay. So the first question that we're going to look at is graphing. How do you graph How do you draw or how do you sketch the graphs of exponential functions? So when you look at this question here, first of all, you have to identify what is called the horizontal asymptote. So the horizontal asymptote implies that it's going to be y being equal to, just get this number here. So the horizontal asymptote that we have now is y is equal to 2. All right. So again, the other thing that you need to know now is you draw this, the table of values. Okay. Then you begin to try to test the numbers. You can first start by putting 0 where there's x. So when you put 0 there where there's x, you get 3 raised to power 0, you get 1. 1 plus 2, you get 3. You try to put 1 there. When you put 1, 3 raised to power 1 is the same 3. And then 3 plus 2, you get, so when you put 1, 3 plus 2 there, you get 5. Yeah, so now from there, it's now easier for us to sketch the graph, to sketch the curve. So we have 1, we have 2, we have 3, 4, 5, 6. So we have 1, there's 2, there's 3, there's 4, there's 5, there's 6, and then we have 7. Yeah. So from there, what we do is we first draw the horizontal asymptote. Okay, sorry for drawing a bend line. Okay, so that is our horizontal asymptote y. Y is equal to 2. So make sure that you draw your xy plane with all that it requires. Okay, so from there what you do is, after drawing the horizontal asymptote, you can now try to plot these numbers. So we have 0, 3, which is this point there. We also have 1, 5. So here we have 1, we have 2. Sorry. So it's this point. So now here we can now draw, starting from the horizontal asymptote, like this. So this is how you basically sketch the graphs of exponential functions. Then you find the domain. The domain is simply, you can plug in any number there from negative infinity to positive infinity, like that. Then you also talk about the range. So the range always starts from the horizontal asymptote up to infinity. All right, so this is how you basically sketch the graphs of exponential function. Actually, this was just a revision. So let us now look at how to find the domain of exponential functions and logarithmic functions. So what you should bear in mind, okay, before I say out this point, let me first find the domain for the first one. The domain for the first one, domain for all exponential functions is negative infinity. Almost all the exponential functions is negative infinity, comma, positive infinity. Yeah, sorry. And then this is for the first question. Now let us find for the second question, this question there. So g of x is equal to log 2x 2 plus 5x. So in other words, what we're trying to say is what is in the brackets there is not always supposed to be below or equal to 0. It's not supposed to be less or equal to 0, meaning that 2 plus 5x should always be greater than 0. So when you take this 2 to the other side of the equal sign, you're going to have 5x greater than negative 2. So when you divide both sides by 5, you find that your x is greater than 2 over 5. I mean negative 2 over 5. So the domain will now be equal to, just take this into set beta notation, into interval notation. So meaning the value of x, or rather the domain, let me just write d. So d will now be equal to, from negative 2 over 5 to positive infinity. So this is the domain for the second question. Let us now find also the domain for the third question. So you first take the first part there. We said this value of x is always supposed to be greater than 0. So this value of x there is always supposed to be greater than 0. So this is our first domain. So I'll name it as d1. So my d1 is equal to from 0 to infinity. So I also need to find the d2, meaning I'm going to use now this part. So I'm going to say this 2 minus x is supposed to be greater than 0. So meaning when I take this 2 to the other side of the equal sign, I'm going to have negative x greater than negative 2. So when I divide both sides by negative, I'm going to have x. Remember, when you divide by a negative, when you're dealing with greater or equal to, I mean when you're dealing with inequalities, so the sign changes there. So this implies that we're going to have our d2 being equal to negative infinity, because it's saying x is less than 2, negative infinity up to 2. So now for us to find the domain is just equal to d1 intersection d2. So we find the intersection set between d1 and d2. So my domain is just going to be equal to, so we can see to say 0 is common in both sets. And then we can also see that this 2 is there, even there, the 2 there is there. So this is our d. This is our d. I'm sure by now you guys will not have problems in finding intersection sets. Right. So we proceed to the next question. So we have this question here. This question is similar to the question that I solved in the previous lecture slide, lecture 16. It's just that this one we're using e. So this e, our main aim is to express this e to the power for x in terms of e to the power to x. So this is going to be e raised to power 2x, and then in brackets, and then squared. When you multiply this 2 times 2 there, you get back to that. Then we say plus 4 e raised to power 2x say minus 21 is equal to 0. So here now we can say let p be equal to e raised to power 2x. So where there is e to the power 2x, we replace with p. So we're going to have something like this: p squared plus 4p minus 21, which is equal to 0. So we find the factors and the product and the sum there. You discover that you have something like this: p squared, and then this is going to be negative 3p positive 7p. Okay, minus 21 is equal to 0. So from there we can now factorize. We factor out the p here, so we're going to remain with p minus 3, and then here we factor out the positive 7, so we're going to have p minus 3 being equal to 0. So there we now write p minus 3. So we have another p plus 7 there being equal to 0. So when we equate this p minus 3 to 0, and we also equate the p plus 7 to 0, the first p that we're going to have is p is equal to positive 3, and then the other p that we're going to have is p is equal to negative 7. So what is now going to happen here is we recall to say, so we say recall that p is equal to e raised to power 2x. So meaning we can replace where there is p, we put e to the power 2x. So we first take p is equal to negative 7. So where there is p, we put e raised to power 2x is equal to negative 7. So we're going to introduce the ln on both sides of the equal sign. So this is what we're going to have: ln negative 7. And we all know to say the log of a negative number or the ln of the negative number does not exist. So this side we just write no solution. So this side no solution. So we move on to the next part where we have p being equal to 3. P is equal to 3. So where there is p, we put e to the power 2x is equal to 3. We introduce the lns on both sides, and then we have is equal to ln 3. So according to the rules of logarithms, these 2x can come down, so we're going to have 2x and then ln e, which is equal to ln 3. So this ln e is equal to 1, because this ln is a special logarithm with the base e. So meaning it's a log with base e. So meaning down here there's e, and then ln e base e is equal to 1. So what we have is we have our 2x there times 1 is equal to ln 3. So 2x is equal to then 3 over 2 over 2. So mean our value of x is nothing but equal to ln 3 over 2. So this is the solution for this question. This is our answer. So let us now see, let us proceed. We check the other questions. Okay. Check the other questions. So we have this question which says solve each of the following equation. Yeah, so here I'm going to solve these equations. The first equation that we have, this is just revision. We did this in the previous lecture slide. So we have log 3 base y is equal to half. So meaning we just convert this to exponential. How do we do that? This is always the power, this y is always the base. So we're saying y is the base, and then half is the power. So meaning this 3 we just put it this side, and then this y to the power half is just the same as the root of y is equal to 3. To get rid of this root, we introduce the square. We square both sides. So meaning y is equal to 9. 3 raised to power 2 is equal to 9. So this is the answer for the first part. We move on to the second part, this one here. So when you have such a question again, you can see to say this can okay, let me just write it. So we have x squared plus 8 is equal to, when you're adding two logs, it means that you are multiplying these numbers. So here we're multiplying this x times that 6. So we're going to have, oh sorry, this is in base 2. So we're going to have log 6x in base 2. So when you take this log to the other side of the equal sign, you are going to have log this is what you're going to have. Then we're going to have minus log 6x base 2 is equal to 0. So when you are subtracting, meaning we're dividing this x plus 8, I mean xy plus 8 and this 6x. So meaning we're going to have something like this. Log x squared plus 8 over 6x. And then this is in base 2 is equal to 0. So here we can now convert it to exponential form. So this 2 raised to power 0, 2 raised to power 0 is equal to this part, which is x squared plus 8 over 6x. So any number raised to power 2 is equal to any number raised to power, any number raised to power 0 is equal to 1. So where there is 2 raised to power 0, we can just replace with 1. So when you cross multiply there, 6x times 1, you get 6x. And then you have this is equal to x squared, and then plus 8. So you take this 6x to the other side of the equal sign, meaning you are going to have a quadratic equation which will be like this, minus 6x is equal to 0. So here, you guys, there's no one can fail to solve a quadratic equation by this level, I'm sure. So you say 6x then plus 8 is equal to 0. All right. So this is the this is what's this? This is the equation, and then so I want you to finish it up. So the values of x that you are going to find are x is equal to 2 and x is equal to 4. These are the two values of x that you should find after solving this quadratic equation. All right, let us now go on to this question. I think it's the second last question. So we're saying solve the simultaneous equation. We have 2 raised to power x is equal to 4. Choose this part. So we have 2 raised to power x is equal to 2 raised to power 2. So meaning we can find, we have already found the value of x to be 2. So the value of x here is simply 2. And then we also now deal with this other equation. So we have y, oh sorry, not y, but 2. Okay, we have 2 log y is equal to, so log 2 plus log x is just the same as log 2x. Yeah, they are all in base 10. So when they are in base 10, you don't normally indicate the log. So these two can go up there. So we're going to have something like log y raised to power 2 is equal to log is equal to, so if you don't want to be writing log, you can just be writing log. It's just the same thing. So log 2x. So here there are some people who say this and that can cancel, these logs can cancel, but that's not the case. Yeah, if you want, you can say they can cancel, but it's not the case. You just need to show the correct steps. So what you do is you take this to log 2x to the other side of the what's this, the logarithm here. So you're going to have y squared and then minus log 2x is equal to 0. So when you have such an equation, when you're subtracting, it means that you are dividing. It means that you're dividing, you're having something like this, log y squared divided by 2x is equal to 0. So this is in base 10. When they are not indicating the base there, it means that it's in base 10. So meaning the base is 10, the power is 0, and then this is equal to y squared over 2x. Yeah, so 10 raised to power 0 is just 1. Then we have y squared this side over 2x. When you cross multiply there, you have your y squared being equal to 2x. Then your y squared is equal to, the value of x we found is 2. We said x is equal to 2. So we put where there's x, we put 2. So we're going to have y squared being equal to 4. So the value of y is nothing but plus or minus the root of 4. So y is equal to plus or minus 2. So now you can, yeah, y is equal to plus or minus 2. So this is the solution for this question. Y is equal to plus or minus 2 and x is equal to 2. Okay, let's do our last question, and then there's an exercise at the end of this slide which will be required to submit before Thursday. All right. So Question 6 is saying, suppose that a certain substance has the half-life of 20 years. If there are presently 2,500 milligrams of substance, then the equation Qt is equal to that. Use the remaining, use the amount remaining after t years. How many remains after 40 years? So this question is just so it's straightforward. There's nothing that you should stress about in this question. There are some questions I tried to look for one which are a little bit complicated on exponential decay, but unfortunately I didn't find any. But as time goes on, as we're going to be doing practical questions on other topics, if I come across any exponential decay or exponential uh, growth or exponential growth, uh, I'll bring it up. We're going to do it any day, anytime. Okay. So this is what we have. So they're telling us where there's t, we put 40. We just replace where there's t, we put 40. So we have 2,500, and then we have 2 where there's t, we put 40. So we're going to have negative 40 divided by 20. So this now gives us 2,500, then 2 raised to power negative 2. Okay, so this will give us 2,500 2. This can also be written as 1 over 2 to the power 2. But we know to say 2 to the power 2 is nothing but 4. So we are going to say 2,500 multiplied by 1 over 4, which gives us 2,500 divided by 4. And then our final answer will now be equal to, should be 625, I think. Yeah, so you try to divide that, you get 625 milligrams. Yeah, so this is basically that. These are the basic things that you need to know about exponential growth and decay. But I'll try to look for some questions which are a little bit complicated than this one. This one was straightforward. And then I'll bring them up, we'll come and solve them, more especially during the tutorial. All right, so at the end of this slide, there is this exercise, which is a simple one, and it's only one question, which says solve the simultaneous equation. You're going to solve this simultaneous equation. Once you solve it, please submit. Then after submitting, I'll go through it, and then I'll correct you where you are wrong. All right, so thank you very much for attending to today's lecture. Make sure that you don't miss next week's, the next lecture that we're going to have. Yeah, don't miss the next lecture, because since we've now concluded with what's this, with logarithms, we may start a new topic on Thursday. Yeah, we may start a new topic on Thursday. So please make sure that you understand. Make sure that you attend that meeting. Every time you miss the first points on each and every topic, you always tend to get lost on the way. So the first points that I'm going to be giving you, the first points, the introduction of every topic is very important. Yeah, don't underestimate it to say maybe introduction part is simple. Yeah. So make sure that you attend the next lecture. Shalom, shalom.